Recall what our goal is here. We're trying to make these equilibrium equations match the compatibility equations, and the compatibility equations went through some manipulations to get stresses in there. So currently we're at this point where we have the second derivative of tau with respect to x and y. We got a 2 over here, so let's figure out the 2 first of all. So it's starting to get close. So if we looked at the first equation in here, we can solve for this term here. So the second derivative of tau with respect to x and y is minus the second derivative of sigma x minus the body force. So I brought those over to the right hand side. This equation, I'm going to isolate the second derivative of tau, bring these other two to the right hand side, so those become minuses. So I have minus sigma y, twice differentiated with respect to y, and then the minus the body force here. And since I need 2 of them, I'm going to add these together. So simply adding these together means it's this term plus this term. So we got 4 things in this parenthesis. So now we're getting really close to this. And the only thing that's missing is the 1 plus nu. So let's add, let's multiply a 1 plus nu to both sides. So the left-hand side of my equilibrium equation has been transformed through a lot of little exercises, but all of them are pretty straightforward to this expression here. And you may be wondering why I'm hanging out of the body forces. I'll explain that shortly, okay? So the final thing is that this is the left-hand side of the compatibility, and this is the left-hand side of the equilibrium. This is the right-hand side of the compatibility, and this is the right-hand side of the equilibrium. So we set the right-hand sides equal to each other. We set up this gigantic equality. And we have this big expression in here, which looks a little messy, but I think you could follow every single step in here. And my printing is very messy. I did this on a train a little while ago. And we clean up some terms. A couple of things cancel. And I was giving myself a check mark here where we ended up with equation 4.18. So we have the partial derivative twice with respect to x of the sum of these two, the partial derivative with respect to y twice of the sum of these two, is equal to something very interesting here. You may be wondering, why am I hanging on to these body forces? And notice they actually do have a material property in here. They have a material property. Now, there's not much left. It's just Poisson's ratio, but it's still significant. And this is going to be extremely fascinating in about a minute or so.